So last week I attempted the chapter math counts competition, and this was problem 29 on the contest. It was a relatively challenging problem. I did not get it the first time around, but when I went back and took a look at the solution and worked through the intricacies myself, I found that there were a lot of interesting moving pieces, and I wanted to share the solution with you all this week. So the question asks how many ordered pairs of positive integers, a and b, satisfy the following equation. 7ab divided by a plus b equals 2025. Well, there's a little bit of a problem with the equation as written, which is that a plus b is not a product. So first we want to perform some algebraic manipulations to reach this point. We just multiply through by a plus b and pull everything over to the left-hand side of the equation. And now we're starting to see that the left-hand side has a couple of numbers that have an a in it, a couple of numbers that have a 2025 in it. So we want to do a technique that's similar to completing the square on the left-hand side of this equation to create a product on both sides that we can utilize to better figure out which prime factors our product will have to have. So first we multiply through by 7 to create 7 squared ab and a number of other terms. And then the trick is going to be to add 2025 squared to both sides, so that eventually we reach this equation at the bottom here, 7a minus 2025 times 7b minus 2025 equals 2025 squared, which when we prime factor that is going to be 3 to the 8th times 5 to the 4th. And now we want to notice that this equation is symmetric in both a and b. So without loss of generality, we'll assume that 7a minus 2025 is the smaller of the two factors, or they might both be equal, being 2025 each. And now we employ a trick that is relatively common when you look at Diophantine equations like this, which is that because 3 and 5 are prime numbers, and 7 is relatively prime to both 3 and 5, we can consider the product on both sides modulo 7 to simplify some of our calculations. If we had to try and figure out 7a minus 2025 equals some factor of 2025 squared, that would be a relatively difficult problem to solve. But when we consider this modulo 7, given that 7a minus 2025 is congruent to 5 mod 7, all we have to do is test all the factors less than or equal to 2025, for which 3 to the x times 5 to the y is congruent to 5 modulo 7. When we do that, there aren't that many factors to test, but you would have to do this by hand. We find out that there are 4 factors less than 2025, which are congruent to 5 modulo 7. It's 5, 75, 243, and 1125. And then the last piece of the puzzle, we have to remember that because of symmetry, this number could work for either a or b in our equation. There is a counterpart. So there's going to be 4 times 2 is 8 total pairs.